Good morning, my dear students of grade 10. Today we are continuing our fourth chapter. In our first class, we discussed about Newton's universal law of gravitation. In our second class, we discussed about variation of force of gravitation while changing mass and distance of two objects. Okay, today we are going to continue with the title Gravity or Weight. Later on we'll discuss about acceleration due to gravity. Well, many people confused with gravity and gravitation. Okay, they think that gravity and gravitation are same thing. They usually use the term interchangeably, but gravity and gravitation are not the same thing. Okay, like this is planet A and this is planet B. Okay. Now, what amount of force exists between both of them? We know that planet A also applies some amount of force and planet B also applies some amount of force. Okay, and the aggregation of these two forces and the interaction force between these two planets is the force of gravitation. Okay, and so gravitation is a phenomenon. But gravity means what amount of force is applied by one of the body. Okay, what amount of force is applied by one of the body to attract another object. So in other words, you can say that this Fa, you can see this term. Okay, this term is virtually the gravity, whereas this term is gravitation. That is the difference. Okay? Gravitation means the overall force of attraction between two bodies having mass. Okay? And gravity means the amount of force applied by a body to attract another object toward its center. Okay, that is gravity. Okay? Now, gravity you can define as gravity is the attraction force of a celestial body on another object toward its center. Okay? Gravity is the attraction force of a celestial body on another object toward its center, whereas we defined gravitation as the process or phenomenon in which two objects having mass attract each other toward their center. Okay, so this sound to be same term. Okay, but they are not same. And most people they tend to use these terms interchangeably, but they cannot be used interchangeably. Okay, now come to the term weight. Okay, say this is an earth. Okay, and here is an object. The earth attracts object toward its center by certain amount of force. Yes, and that force is called gravity. Now, what amount of force is being applied on that object by earth? That is called weight. Okay, so force equals to weight. That means the amount of force applied by the earth or planet on another object is called weight. Okay, like if I say my weight is 750 Newton, that means the earth applies 750 Newton of force on my body. If I say the weight of a car is 10,000 Newton, then that means the weight of that car is, so that means the earth applies 10,000 Newton of gravity, force of gravity on the car. Okay, like if weight of an object is just 1 Newton, that means the earth is applying only 1 Newton force on that object to attract toward its center. So weight is different from mass. Yes, you all know that. Weight is defined as the amount of gravity applied by okay, let me say celestial body, because if I say earth, that would be wrong, because gravity is exerted not just by earth but by other planets, satellites and stars as well. Okay, even black hole also applies gravity. So every object, every body in the universe, they exert gravity, they possess gravity. Okay, that's why I need to say celestial body on an object is called weight. Okay? And SI unit of weight is Newton. Why? Newton is the SI unit of force, but weight also have SI unit, because weight is the amount of force. Weight is same as force. Okay, in magnitude, weight is same as force. And mathematically, we can calculate weight, that means F, by using the formula m into g, where m means mass of the object. Okay, so it clearly shows that if an object has more mass, then it will have more weight. If an object has less mass, then it will have less weight. And g means acceleration due to gravity. Okay, due to gravity the object falls down. Yes, and if you put some object at some height, then due to gravity it falls down, but it does not fall with constant speed, same speed. It does not fall with same speed. Okay, its speed keep on increasing, and per second time, by what amount will its speed increases, that is known as acceleration due to gravity, g. Okay, so the product of m and g shows the weight of that object. Okay, now let's discuss effects of gravity. Okay, I guess we haven't discussed about effects of gravitation yet. Yes, okay, we'll discuss that also. Okay, because of gravity we are able to stand, walk, run, etc. If there is no gravity, then we will just be flowing around. Okay, we won't be able to control our movement. And because of gravity, falling of object also occurs. Effects of gravity, objects fall on the surface of earth because of gravity, and because of the same we can build, are able to construct buildings. Because of gravity we are able to build. Say you put a rock down here, you need to put another rock. Okay, here is another, and you need to put another rock here, and they hold together because of gravity, because of their weight downward. If there is no gravity, then you put the rock here, and before you put another rock, it will simply float around, it will not stay here. Okay, so without gravity, construction of building would not be possible. And similarly, flowing of river, you know that water flows from higher altitude to lower altitude, or high level to low level, so and that happens because of gravity. So river flows because of gravity. Okay, and similarly another important feature is existence of atmosphere. Existence of atmosphere. Okay, earth has atmosphere all because of gravity. If there was no gravity, then all the air of earth might simply escape the earth and move away and diffuse into the space. Okay, so these are some useful effects of gravity. Okay, because which are essentially useful for human. Okay, now let's cover up what we forgot to discuss: effects of gravitation. Now see, let's say universe. Okay, let's start from here. Moon rotates around Earth, isn't it? Moon rotates around Earth, and Earth rotates around Sun. Okay, see, Moon rotates around Earth, and Earth rotates around Sun. Whereas Sun also rotates around galactic center. Okay, let me extend it. Okay, sun also rotates around galactic center, and the galactic center again rotates around the nucleus of the universe. It also keeps on rotating around the nucleus of universe. Okay? Can you see the link here? Moon rotates around Earth, Earth rotates around Sun, Sun rotates around galactic center, and galactic center or galaxy itself rotates around the nucleus of universe. Okay? You see, everything is rotating everything else. That means virtually moon or Earth is also rotating around the nucleus of the universe. We might say that in studying solar system, we might say that sun does not move around. Sun is stationary. Isn't that what galaxy told us? Sun does not move around. Sun is stationary and Earth moves around the sun. But the fact is, sun is also not stationary. Okay? In relative to Earth, sun might be stationary, but in relative to galactic center, sun is also moving. Just like Earth is moving around the sun, sun is also moving around the galactic center. And the galactic center or galaxy is also moving around the nucleus of universe. So the universe overall is actually spinning. Okay, and this is all because of gravitation. Why do the bodies, celestial bodies, rotate around each other? That is all because of gravitation. Okay, see, this is Earth, suppose, and this is Moon. Certain amount of certain amount of gravitational force exert between these two. Okay, as a result, Earth also moves toward Moon, and Moon also moves toward Earth. Okay, that means the Moon is but definitely the force applied by Earth is much more than force applied by Moon. So Moon is moving toward the Earth. Actually, Moon is falling toward the Earth. Okay, but if there were no other objects, influencing object, then Moon would simply collide with Earth. Moon will simply collapse to the Earth and it will vanish. Okay? But there is a sun. Okay, because of sun, the okay, because of gravitational force between Earth and Sun, Earth is also moving towards Sun. Yes, and when Moon reaches the position of Earth where it was, by the time the Earth has already changed its location. Okay, so Moon has to change its path as well. The movement path of Moon will also be changed, and that gives the effect of rotating around the Earth. Okay. And the same thing is happening between galactic center and the sun as well, and the same thing is happening between galactic center and nucleus as well. See, because of their force of attraction, because of gravitation between each other, all the celestial bodies are moving or rotating around each other. Okay, so that is the first effect and first and most prominent effect of effect of gravitation. You say moon rotates around the earth around the sun, and sun around the galactic center, and the galactic center around the nucleus of the universe. Okay, this is the most prominent and most important effect of gravitation in the universe. And second effect of gravitation is, because of gravitation between sun, moon, and earth, tides rise and fall in ocean. Because of gravitation between sun, moon, and earth. Okay, so these two are major effects of gravitation, and if the question becomes tricky, which asks you to state more than two effects of gravitation, then you can split it. Okay, you can split this point into three different points. Like moon rotates around, or satellites rotates around the planets, first point. Planets rotate around the star, second point. Stars rotate around the galactic center, third point. And galactic center rotates around the nucleus of the universe, fourth point. Okay, you can split this point into several points if you need to state more than two effects of gravitation. Okay, now let's go to another topic. We have acceleration due to gravity. Okay, acceleration due to gravity. Now you know what is acceleration. Let's start from there. Acceleration means change in velocity per unit time. Okay, acceleration means change in velocity per unit time, and the title suggests acceleration due to gravity. How does gravity changes velocity of an object? That definitely happens when an object is falling toward earth. Okay, if you suppose this is an earth, yes, okay, and if you hold an object at certain height having mass m, if you hold an object at certain height, then at that height you know its velocity is 0 meter per second. Okay, but as soon as you let it go, its velocity keeps on increasing, isn't it? It increases, and at a time of 1 second its velocity reaches okay, let me take it 10 meter per second for simplicity of calculation. Okay, in 1 second its velocity reaches 10 meter per second, and after another 1 second then its velocity reaches in 10 meter per second, and 10 meter it becomes 20 meter per second. See, and in another 3 second time its velocity reaches 30 meter per second, and in another 4 second time, by the time it hits the ground, what I'm showing here is I assume that the object hits the ground at 4 second time. At 4 second time its velocity becomes 40 meter per second. See, when an object is falling toward earth because of gravity of earth, the velocity of falling object keeps on increasing by constant rate. Now you can see here in this first instant, its velocity is changed by 10 meter per second per second. That means 10 meter per second square. 10 meter per second in 1 second. That means 10 meter per second square. See, and in next instance, its velocity increased from 10 to 20. Means what is the change of velocity here? Here also 10 meter per second square. And in third instance also 20 to 30 means 10 meter per second square, and its velocity is constantly changing by same rate. Okay, now this is acceleration. What we have shown here is acceleration, isn't it? The change in velocity per unit time. And what is causing this acceleration? What is causing this acceleration? Definitely it is caused by gravity. That's why it's called acceleration due to gravity. The acceleration which is caused by gravity. Okay, any confusion? See, the gravity causes an object to fall. Okay, and when an object falls, it does not fall with constant velocity. Okay, the velocity of falling object keeps on changing at constant rate. Okay, and that change in velocity per second time is known as acceleration, and this acceleration is caused due to gravity. That's why it is termed as acceleration due to gravity. Now let me define it. Acceleration due to gravity. Okay, start from here. Gravity causes any object to fall toward its center. Okay, and the falling object does not move with uniform velocity. Its velocity keeps on increasing at a constant rate, which is called acceleration due to gravity. Okay, this definition is quite long, isn't it? It is a long definition, but it is a conceptual one. That means if you understand the concept behind acceleration due to gravity, you can make this definition on your own. Okay, gravity causes any object to fall toward its center. The falling object does not move with uniform velocity. Its velocity keeps on increasing at a constant rate, which is called acceleration due to gravity. Or if you want to summarize the definition, you can also say that acceleration due to gravity is defined as the rate of change of velocity. Okay, this is the same as general definition of acceleration. The rate of change of velocity of whom? Of falling object under the influence of whom? Gravity. Okay, if an object is falling due to gravity, then its acceleration, the acceleration of that falling object is called acceleration due to gravity, and its symbol is, you all know, small g, and SI unit is same as acceleration, meter per second square. And you need to know some few data. G on earth, okay, at pole, it is 9.832 meter per second square at pole, and at equator it is 9.78 meter per second square. See, the value of G is different in different part of earth. Why is that so? We will discuss shortly. And acceleration due to gravity on moon is 1/6 of earth, and it is roughly 1.7667, okay, meter per second square. And G on Jupiter, Jupiter has very large acceleration due to gravity. It is nearly 25.84 meter per second square. Okay, you need to memorize these data. They are going to be useful while solving numericals. Okay, so acceleration due to gravity on earth, at pole it is 9.8 and at equator it is 9.78, and on earth we take it as average to be 9.8 meter per second square. Average, it is 9.8 meter per second square. Okay, and on moon, the value of acceleration due to gravity is 1.7667. okay, so it's 1.67, sorry, 1.6776. okay, and the palindrome got me confused. Okay, 1.6776 meter per second square, and value of G on Jupiter is 25.84 meter per second square. Now why does the value of G changes or varies from place to place? Okay, if it is different from place to place, and let alone be it from one planet to another planet, or planetary star, or different celestial bodies. Okay, if even on earth it is different on different places, then obviously it is going to be different in different planets. Okay, now why is that so? We are going to show that. Okay, let us suppose, okay, you understood the question, yes? The question is, why does the value of g vary from place to place? Don't forget to write down, or don't forget to take the note. Why does the value of g vary from place to place? Okay, let us suppose mass of a planet be capital M, radius be small m, radius be capital R, mass of object be small m. Okay, then this is the earth or a planet on whose surface you have kept a mass. Yes, now the distance between these two objects, the planet and the object, is virtually the same as radius of the planet. Okay, we are keeping the small m, we are keeping a mass on the surface of a planet, which means distance between these two objects would be virtually the same as the radius of the planet, because we have already discussed about force of gravitation in universal law. It is directly proportional to product of two masses and inversely proportional to square of distance. Okay, now what we need is mass of two objects and distance between two objects. Mass of one of the object is capital M, another object is small m, and we need distance between these two objects. Okay, and you can see the distance is virtually the same as radius. Okay, now as you know, F is equals to, okay, from Newton's universal law. Okay, Newton's universal law gives us F is equals to G. We know it is F equals to G m1 m2 by d square, isn't it? But in this case, mass of first object is capital M, mass of second object is small m, and distance between them is capital R square. See, F equals to G capital M small m by R square. This is our first equation. And also from Newton's second law, you have studied Newton's second law in grade 9. From Newton's second law we have F equals to m into G. This be our second equation. Okay, and both of them gives us same value F. Okay, this also gives us weight of object, and this F also gives us weight of object. Okay, now from equation 1 and 2, what we get? From equation 1 and 2, we get that m into G is equals to capital G capital M small m divided by R square. Now this is also mass of object. This is also mass of object. We can cancel it from both sides, or what we get, G is equals to capital G capital M by R square. Okay, now see here, capital G is definitely a constant, a universal constant, isn't it? Capital G is a universal constant, and M is variable. But if we are talking about same planet, if we are talking about single planet, then M is also constant. Okay, and M is constant for a planet. It means both of these terms are constant. Okay, capital G is already a universal constant. Okay, and capital M is constant for a planet, and it gives us that G is variant on R square. G is dependent on R square. Okay, if they are constant, then their value is not going to alter the value of G. Okay, but value of R is going to alter the value of G. See, if a planet has more radius, then it will have less acceleration due to gravity. If the planet has if the planet has less radius, then it is going to have more acceleration due to gravity. Or if we are talking about different planet, okay, in case of different planets, then we need to take another relationship as well, that is G is proportional to M. Okay, in case of, if we are talking about different planets, then we must consider about its mass as well. Okay, but in general, this is not asked. In general, see, what is the question? we are deemed to show that it is different from place to place, means place to place of the single planet, of the same planet, like the equator of Earth and pole of Earth. Why is value of G is different at equator of Earth and pole of Earth? Or why is it different in Janakpur and Sagarmatha? The questions like that. Okay, that means we have to consider the value of small g in different places on the same planet. Okay, that's why we do not need to show this. Okay, they only up to here we need to show proved. Any confusion up here? Okay, now next title is here, acceleration due to gravity at a particular height. This is just a variation. We know that G is equals to capital G capital M by R square, where on the surface, yes, on the surface. And you need to note it down here, R. Why did we consider here R? It must be D, isn't it? It must be distance between two objects according to Newton's universal law of gravitation. But why did we consider it to be R? Because when an object is on the surface of Earth or planet, then a distance between them is virtually the same as radius. But when an object is kept at certain height, then the distance between these two objects, will it be same as radius? We need what here in denominator, what do we need? We need distance between two objects, isn't it? But when the object is at certain height, not on surface, then distance between them two will not be equal to R. It will be GH equals to GM by R plus H whole square. It will be R plus H whole square. This is R and this is H. So you need to add R and H to get the distance between two objects. Understood? At certain height. Okay, or in numerical, if you are given all the data, you can directly use this formula, but sometimes you are not given all those data. Okay, in that case, what do we need to do? Let me get a paper. Okay, now from dividing, okay, this will be equation 1 and this will be equation 2. Dividing equation 2 by 1, we get divide the terms on left side by left side, okay, GS by GS, and divide the right terms on right side by right side. Okay, now here it is not a problem, GS by G, it's not a problem, but here you can see it is a mess. Yes, there are double fraction within fraction, and you know this is the main fraction. And when you have to deal with such situations, fraction within fraction, what do? We simply inverse the denominator. Yes, fraction in denominator. The fraction in numerator, it is the same, okay, and it becomes the main fraction. Multiply the fraction in denominator is inverse R square by GM. Now see, GM and GM, they are same terms. We can cancel them out, or you get GH by G is equals to R by R plus H whole square. See, the numerator also is in perfect square, denominator is also in perfect square, so you can place them in common square. Therefore, it gives you GH equals to G bracket R by R plus H whole square. Okay, this is another relationship. That's this is the relationship between acceleration due to gravity at the surface of Earth and at certain height. Okay, and definitely when you go to certain height, acceleration due to gravity is going to be different. Okay, any confusion up here? I hope not. If you still have any confusion, please go through it once again. See, I'm showing it from the beginning. Acceleration due to gravity at a particular height. Consider G equals to Gm by R square on the surface of Earth, and when you take the object at certain height, then g, the value of g is going to be different. That's why we consider it to be gh, which is equals to gm by r plus h whole square. Now dividing equation 2 by 1, you get, while dividing two equation, what we do, we divide left side by left side. Okay, terms on left side gs by g, and terms on right side gm r plus h whole square by gm r square. And since we have double fraction, what we do, we reverse, or we inverse the denominator, fraction in denominator. So we get gm by r plus h whole square into r square by gm. Okay, gm cancels, that's why we get r by r plus h whole square, and by cross multiplying g, we get gh equals to g r by r plus h whole square. Okay, this much for today. Tomorrow we are going to consider more questions, particularly give reason questions and feather coin experiment. We are going to discuss feather coin experiment and give reason questions related to acceleration due to gravity. Then we have to go to numerical. So stay in touch. We'll continue the lesson tomorrow. Thank you very much.